This is lesson 15, and we're going to be working with trig identities. To start with, let's go over some reciprocal identities. We know that sine theta is the reciprocal of cosecant. So we can say that 1 over sine theta is equal to 1 over cosecant theta. And cosecant theta is equivalent to 1 over sine theta. That's their reciprocal identities. Cosine theta is equal to 1 over secant theta. And therefore secant theta is equal to 1 over cosine theta. Tangent theta is the reciprocal of cotangent, so that would be 1 over cotangent theta. And same thing for cotangent theta is equal to 1 over tangent theta. Okay, so that's our reciprocal identities. Well, what about the Pythagorean identities? Okay, we know that we have sine squared theta plus cosine squared theta equals 1. So we could take solve for one or the other. In other words, cosine squared theta, if we were to subtract sine squared theta from both sides, we would have 1 minus sine squared theta. And the same thing, sine, if we start off with sine squared theta plus cosine squared theta equals 1 and subtracted cosine from both sides, we'd have 1 minus cosine squared theta. We also know that tangent squared theta plus 1 is equal to secant squared theta. And you could also say that if we subtracted tangent from both sides, we could say that 1 equals to secant squared theta minus tangent squared theta. Also, cotangent squared theta plus 1 is equal to cosecant squared theta. And if we subtracted cotangent squared theta from both sides, we get 1 equals to cosecant squared theta minus cotangent squared theta. So let's take a look at some problems. And to start with, if we wanted to simplify some trig identities or some trig problems, if we have, example, sine t times secant t, if we want to simplify that, well, we could say, all right, let's look at the reciprocal of secant, such as sine t times 1 over cosine t. And then we could say, okay, well, this could be sine over cosine. Sine t over cosine t. Well, sine over cosine is tangent, so that could simplify to just tangent t. And that would be our answer. The whole process. It's not just tangent that's the answer, but it's the whole process. Alright? That's involved. So we have to show our steps each step of the way. So let's say that we have sine squared theta, and we have 1 plus cotangent squared theta. And we go ahead and distribute the sine squared to both sides. Sine squared theta times 1. And then we have plus sine squared theta. And then we're going to change cotangent to cosine squared theta over sine squared theta. And we can say that this sine squared theta is over 1, and we can cancel the sine squared thetas, and they go to 1. And so now what we have is sine squared theta plus cosine squared theta, and we know from our reciprocal identities all that goes to become 1. Alright. For this next one, we have secant beta cosine squared beta plus sine squared beta secant beta. Okay, well, let's see, what can we do here? Well, one thing we noticed is we have a common factor here, right? If we can get this cosine squared and sine squared by itself, isolated, then we can get that to be 1. So we can factor out the secant beta. And so that would be cosine squared beta plus sine squared beta. And since that's 1, all we have left is just secant beta. And that's it, where we've simplified that. Okay, and also, if we have something like this, sine theta over tangent theta, and we could say, all right, we could simplify tangent by taking sine theta and making tangent sine over cosine. So we make that sine theta over cosine theta. And we know that if A over B is A divided by B, and that's it multiplied by A times the reciprocal of B. So we can take sine over cosine and flip it. So that gives us sine theta times the reciprocal of sine over cosine, which is going to be cosine theta over sine theta. And we know that the sine thetas can cancel, and we're left with just cosine